Geometry isn't just about drawing triangles, it's the language of the universe. From the screen you're watching right now to the orbits of the planets, everything follows a set of logical rules. Today, we are diving into exercise 9.1. We're going to learn the differences between a guess and a truth, identify mathematical statements, and solve the logic puzzles that build the world. Let's cross the STEM bridge. Logic, patterns, and proofs in geometry. A complete walkthrough of exercise 9.1 from Unit 9th, Geometry and Polygons. Defining the foundations. An axiom and a conjecture. An axiom is a self-evident truth that is accepted without any proof. These are the starting points of logical reasoning. An example could be that the whole is greater than the part. A conjecture is a statement which is believed to be true based on observation or patterns, but not yet formally proven. An example could be that every even integer greater than 2 is the sum of two primes. Let's identify some valid mathematical statements. The rule to consider here is that a mathematical statement must be definitively true or false. Ambiguity means that it is not a statement. For the first part, the difference of 19 and 12 is 7. This statement is true. The second part, minus 2 plus 7 minus 3 is equal to 2. This statement is also true. For the third part, 34 plus 16 is not equal to 50. This statement is false. But you should always remember that false claims are still valid statements. Looking at the fourth part, a plus b is equal to 9. This is not a statement. This is an open sentence. It depends on the variables. For the fifth part, we have an identity which is a plus b whole square, and that is a square plus 2ab plus b square. So this statement is true. For the sixth part, we have 2 plus 2 into 2 is equal to 6. So this statement is also true. Looking at the seventh part, the product of x and y is less than 5. This is not a statement, it is an open sentence. Then let's look at the eighth part. If x is real, then x is less than 0, x is greater than 0, or x is equal to 0. This statement is true, as if we consider x to be a real number, then its values can be negative, positive, or equal to 0. Looking at the ninth part, if A is greater than B and B is greater than C, then A must be smaller than C. This statement is false. It has a logically valid structure, but it is factually false. Then for the 10th part, xy plus z is equal to 12. This is not a statement. And for the 11th part, s minus t is equal to 4, but if s is equal to 4 and t is equal to 0, this statement will be true, not an open sentence as the variables are defined. Now we will be converting some open sentences into mathematical statements. Consider this open sentence. The sum of a and b is equal to 0. How can we convert this open sentence into a statement? There are two ways to tackle this problem. We can define our variable. Suppose if a is equal to 2 and b is equal to negative 2, then their sum will be 0. This is a true statement. And if we want to convert this into a false statement, we can just say that for all positive integers a and b, their sum will be 0. Defining this variable just removes the ambiguity. Now, let's move on to the question 3, which is verification by substitution. Here we need to prove our left hand side is equal to our right hand side by replacing the values of x. For example, in the first part, we replaced our value of x to 2, in the second we did for 5, and in the third we did for 10. Now, basically, the equation that we are given here is x plus 1 whole square plus 5 is equal to x square plus 2x plus 6. Assuming that we put the value of x as 2, we get 2 plus 1 whole square added with 5. That is simply 9 with 5, and that gives us 14. This is our left hand side. Now we will check if we place this same value to the right hand side, and if the verification by substitution is correct. So 2 square plus 2 into 2 plus 6, that gives us 4 added with 4 plus 6, and that is equal to 14. Moving on to our second case, if we place the value of x as 5, 5 plus 1 whole square added with 5 is equal to 36 plus 5, which is 41. And for the right hand side, 5 square plus 5 into 2 plus 6, that is 25 plus 10 plus 6, which is 41. So verified. And for the last case, if x is equal to 10, 10 plus 1 whole square plus 5 is equal to 121 plus 5, and that is 126. For our right hand side, 10 square plus 2 into 10 plus 6, that gives us 100 plus 20 plus 6, which is 126. Now we will move on to pattern recognition and conjectures. If you look at this sequence, we have 1, 3, 7, 15, 31, and we need to find what will be the next number. If you look at the first number and the second number, their difference is of plus 2. Then if you look at the third number and the second number, their difference is of 4. If you look at the fourth number and the third number, their difference is of 8. This basically means that we are taking multiples of 2. So if we look at the number which is 31, the next number will be also a multiple of 2. So that is 31 added with 32. So we get 63. You can use this conjecture formula to find the nth term, which is 2 power n minus 1. Moving on, we will be categorizing mathematical truths. An axiom, it is just a general truth applicable to all fields of mathematics like arithmetic, algebra, and logic. It is broad and it is self-evident, while a postulate is a truth which is specific to a particular field, primarily geometry. It is related to lines, angles, and shapes. Both are accepted without any proof. Now we need to check these parts and figure out whether it is an axiom or a postulate. For the first part, if A is equal to B, then B is equal to A. This will be an axiom. Why? Because we know that this is a symmetric property. It is a general property. Then for the second part, 2 plus 2 make 4. This will be an arithmetic truth. That is why it is an axiom. Looking at the third part, only one line can pass through 2 points. This is a geometric property. That is why it is a postulate. For part 4, if two triangle sides are equal, opposite angles are equal. This will also be a postulate as it is a geometric property. And for the fifth part, the product of two negative real numbers is greater than 0. This is the algebraic property and it is an axiom. Now, moving on to the sixth part, all right angles are equal to one another. This is also related to geometry and it is Euclid's fourth postulate. Now, moving on to sixth part, the whole is greater than its part. This is an axiom. It is a common notion. Then we have if A is greater than B and C is greater than D, then A plus C will be greater than B plus D. This is an axiom as we have the inequality logic. If we extend a line segment continuously in both directions, this will be a postulate and it is Euclid's second postulate. And for the 10th part, the sum of three consecutive even numbers is even. This will be an axiom as we are discussing about number theory. This is the architecture of a geometrical proof. The first part is the statement or the theorem. The second is the figure or the diagram. The third is the given, which is the known attributes. The fourth is to prove, which is the goal. And then after the construction, we have statements, the reasons, and we go to our conclusion. Now, the key takeaways that we learned in this lecture. We learned about logic, which is that statements must be true or false. If we occur with a statement that is ambiguous, then we should define variables. We then talked about patterns, the formula to finding the nth term, which is 2 power n minus 1. Conjectures are formulas derived from observation. Mathematics is just equal to proof. Truths. An axiom is a general truth, while a postulate is a geometric truth. And proofs basically connect our given data to our conclusion using reasons. You've just mastered the logic that holds our world together. You know how to spot a conjecture, define an axiom, and start a proof. A final challenge card is the statement all right angles are equal to one another an axiom or a postulate. Drop your answer in the comment section. If this helped you build your geometry foundation, hit the like and subscribe button to STEMBridge. See you in the next lesson.